When you step outside at night and look up, you will see thousands of tiny glowing dots scattered across the sky. We call them stars. But here is something interesting. Have you ever wondered why we call them stars and not just space rocks? I mean, space is already full of rocks. There are asteroids, meteors, comets. So, what's so special about a star? Well, the thing is, the difference isn't just that stars look brighter. The real difference is much deeper. It is about what they are and what they do. See, an asteroid or a meteor is basically a giant rock, just like the rocks we have on Earth, except they are floating in space. They are made of things like iron, nickel, and stone. Now imagine taking one of those rocks and placing it alone in deep space. What happens? Nothing. It just sits there, cold and dark. The only reason we can sometimes see an asteroid is because sunlight falls on it and reflects toward us. It is actually the same reason why you can see the moon. The moon doesn't make its own light, it simply reflects sunlight. So basically, a rock can't produce its own energy. It can only reflect someone else's light. Now, a star is a completely different story. First of all, a star isn't even solid. You can't stand on it. It is actually a gigantic ball of extremely hot gas, mostly hydrogen and helium. But here is where things get really interesting. Imagine taking a soft cotton ball and squeezing it harder and harder and more harder. Its center keeps getting tighter. Something very similar happens to huge clouds of gas in space. As they become bigger and bigger, their own gravity starts pulling everything towards the center. The center gets squeezed with unbelievable pressure, and because of that pressure, the temperature keeps rising. Not thousands, not millions, but tens of millions of degrees. Now, here is the amazing part. The hydrogen atoms inside the core are being squeezed so hard that they crash into each other. And instead of bouncing apart, they join together. They fuse. Hydrogen becomes helium. This process is called nuclear fusion. And basically, this is the exact moment a star is born because nuclear fusion releases an enormous amount of energy every single second. That energy tries to push outward while gravity keeps pulling everything inward. So you have two powerful forces, one pulling in, the other pushing out. And when those two stay balanced, the star remains stable. That is why a star keeps shining for millions or even billions of years. Now, compare that to a rock. Could a rock ever do this? No. No matter how large you make it, even if you smashed thousands or millions of rocks together, you would simply get a much bigger rock because rocks don't have the huge amount of hydrogen needed and they don't have the conditions required to start nuclear fusion. So, basically, a star isn't called a star because it is bright. It is bright because nuclear fusion is happening inside it. That brightness is just the result. A rock simply exists. A star is constantly producing energy every single second. One quietly floats through space, the other is literally turning matter into light. And that is the simple reason why stars are stars and not rocks.